You're listening to Electrician Live with your host, Paul Abernathy. Well, hey everybody, welcome to another episode of Electrician Live. My name is Paul Abernathy. I want to thank you for joining us on the video, and hopefully you're listening to our live shows every Saturday night at 8 p.m. Central Standard Time over on our YouTube channel, which you can see right up there, as well as on our Facebook page, and that's our Facebook Electrician Live show feed, and you can listen there as well. But we prefer you to listen over there on the YouTube channel. Anyway, you can also watch it on our website, electricianlive.com as well. Okay, so today's episode, we're going to start a series where we take certain images and we post them on our Facebook page, and we allow our members to comment on it. Now, there's no right or wrong as far as how you comment. Go on and comment on it. The only thing that we ask you in this new series, which is going to be an educational series, is that you only comment on things that you see and know. Okay, you don't comment on things that you can't see, like what might be outside of the picture, or sizing of conductors when you really don't know what size are being used. You're assuming these things. A lot of cases also, the bonding jumpers and things like that, equipment, grounding conductor sizing and all that, you really don't know because you don't know all the parameters, and you can't look at an image and you're guessing. And we don't want to guess. So what we want to do is only comment on things that we can see, that we can actually prove. Okay, so that's the whole concept of this series. Now, the images that we post are in no way to call out anybody or to be anything that is supposed to make an electrician look bad or something like that. Absolutely the opposite. We're using it for educational purposes. In many cases, these installations passed inspection. And again, 90.4, the authority jurisdiction, can allow that, even though fundamentally some of these aspects are wrong. It's just a learning exercise that we want to go over here. And so we're excited about doing these, and hopefully we can do a lot more of them in 2020, and many of them will be over on our Patreon, but we want to bring some of those to our YouTube channel so that you can kind of see what we're doing with this moving forward, and you choose whether or not you want to subscribe to our Patreon system later on in 2020. Okay, so let's look at now. Another thing I will say, that all of these videos that we're doing from this point on, and we're at January 25th of 2020, are going to be based on the 2020 National Electrical Code. Now, where there's a reference to 2017, we'll make that note for you, but really we're trying to migrate onto the 2020. And again, most of these things, unless we call them out as a code change, are pretty much verbatim for what it would be in the 2017 code, even though we're focusing on the 2020 code. So the code references you see will be 2020 code, but they probably have something very similar in the 2017, but there were some numerical changes on where you turn in sections and things like that. Okay, so just keep aware of that we're doing 2020. All right, so let's get started in the program. Now, the image that we used, again, is on our Facebook page. So if you want to know where our Facebook page is, you just go to Facebook and do a search on Master the NEC, and you'll be able to find us, and you can subscribe there. I encourage you to subscribe. But also, if you're preparing for an electrical exam, then you can go to our Master the NEC Exam Prep forum, which is a separate forum, and you can get to that one from our Master the NEC forum. The Master the NEC is a more open one where I post all these things like we're going to talk about tonight. And then the one that's for exam prep is very specific to preparing for exam. Now, I have taught over 30,000 students in my years since the 80s, and I've helped a lot of people get their exams. So a lot of the information there is validated over time, and I have some experience in helping write exams around the country. So we're going to try to help you there, okay? So let's kind of get into our presentation. And as you remember, if you visited our Facebook page, you'll see the image here on the left of your screen, and that is a double throw switch. Now let's talk about that first off so we can kind of quantify what we're talking about. Many people said, is that a transfer switch? Okay, well, it's obviously a couple of comments that were made on our Facebook page is the intermixing of emergency circuits with non-emergency circuits. Now, first of all, we only comment on what's posted. Nobody said that it was emergency circuits. Nobody said it was a transfer switch. It was a double throw 800 amp switch, and this is for a chiller. The other aspect of this was that If it was an emergency, it would have to be an automatic transfer switch. Okay, if it was dealing with an emergency circuit, and this was a transfer switch. Okay, so it kind of debunks those two things here. So this is not an emergency circuit. That is not an emergency transfer switch. It is a manual switch. Okay, and we won't get into the semantics of whether it's a transfer because it is a double throw switch. Okay, so at the end of the day, we're going to focus on the fact that it is a double throw 800 amp switch being used for a chiller application. So to me, you see the switch on the right side of the piece of equipment. It allows it to be thrown into whether or not it's the top or the bottom of its aspect. All right, so keeping those basic bare bones, you can agree to disagree. That's where we're going to be in this episode. Now, let's kind of dissect this down and remember I'm going to give you some of the comments that were given on our forum, and so that I can address those. So I addressed the first one. There's nothing that was said that this is emergency circuits. So when people say there's emergency circuits mixed with regular feeders, that is not the case in here. It's not what we see. So they're not emergency. The other question is, can you have supply and load conductors in the same raceways? Absolutely. It's done in closures all the time. It's not a problem. And we'll get into whether or not what that box is above the switch as well in here second. So it's done all the time as long as the conductor's insulation is the same and you get it at same rating. Not a concern. Again, we're not talking emergency aspects here. We're talking just general feeders, general branch circuit applications. Okay. Now, the first thing that I run into when I look at some kind of installation like this is I start at the very top. And the first thing I run into is this box at the very top of this switch. Now, I noticed that this switch isn't a panel board. It isn't a switchboard. It isn't a distribution center. It isn't a meter center. It is a switch. And I look at it from that aspect of it. Now, typically, the box above this is going to be either considered by many, either an auxiliary gutter, or it's going to be considered a metal wireway. Incidentally, I'm of the belief that auxiliary gutters are constructed, designed, and they walk and talk and everything like a wireway, a metal wireway. Okay. Now, there's some limitations on what can be in a gutter versus what can be in a wireway. So that's where you start to differentiate when it comes to the code, what can be in there and what can't be in there. Okay. So that's kind of some of the determinations. The other determination would be how far it goes. For example, auxiliary gutters are limited to 30 feet, whereas a metal wireway is not. So there's some limitations. So when I'm starting to differentiate the difference between auxiliary gutters and metal wireways, or even non-metallic wireways, I have to start differentiating for where the location is and what their use is, because generally they're constructed very much the same way. Now, most auxiliary gutters are listed, but not all wireways are listed. Okay, it depends on where they're going to be used and condition of use, whether it's a wet location or something like that for a wireway. So there's other things that can play a role on that. But in this video, we're going to assume that there's some people in the camp of an auxiliary gutter, and there's some people in the camp of a wireway. Okay, because again, you can debate it until you turn blue. My personal opinion is that this is not an auxiliary gutter because it is not supplemental wiring space for a meter center, distribution center, switch gear, or switchboard as defined of what those items are. Okay, so that's my position would be on that. I think it more replicates a wireway in this application. But again, wherever you may fall, it's totally up to you. You can agree to disagree. Feel free to thumbs down. I won't show it anyway, and it doesn't matter. So now let's go on and start out by doing this. Let's assume this installation is an auxiliary gutter. And that's where your camp is. You're in the camp that it's an auxiliary gutter. All right, so if we're assuming it's an auxiliary gutter, let's look at some concerns here that we might have. Now, on our forum, on our Facebook forum, there was a lot of posts that said, for example, and I'll distill some of these really quickly. It says that, okay, what about this raceway over here? It's not secured. If it's rigid metal or EMT, it's got to be secure. Well, the image stops right here. So just because it isn't secured right here on this Kindorf or strap right here does not mean it's not compliant, because you can secure it up to 3 feet from its termination. So over here could be another one of these straps. We don't know what is there. Okay, could they have put one here? Well, it doesn't seem like it goes up far enough, so that's why they didn't put a strap there. But it might be one out here. So we're not going to assume things that we don't know. Okay. Other people commented that the conductors weren't sized right. Well, if we know this is an 800 amp device, and it could be 250 kc mil copper, which is good for 255 amps each, and we're paralleling it, obviously we see there's 3. So then that would be 765, I believe, in amps. Under the terminal limitations of the 75 degree, then if the calculated load doesn't exceed that value, then I can terminate on an 800 amp device because it doesn't exceed, okay, 800 amperes. All right, so we can assume that, if you will. And then once you know the sizes of the conductors and we know it's an 800 amp overcurrent device, then we can calculate out the size of the equipment grounding conductor and all those type of things. However, I don't know what sizes we have here. It passed the inspection. We have to assume it's sized right. And the reason I say that is because perception can always be difficult. If you look up in the actual gutter / wireway, those conductors theoretically, because of their position, look larger than what we see at the terminations down in the actual switch. So perception can play a role here. So that's why I don't comment that on pictures. We assume that they're sized right. Okay, so I'm not calling that out. And so when I do these videos, we're calling out things that we can see as a learning experience, not things that we're speculating on. We just don't want to do that. I know people do, and that's human nature, but that's not what we're doing. Other people comment on the tie wraps and things like that. Whether you like tie wraps or you don't, they're permitted. And whether you think this is neat or not, many people thought it's a neat installation. That doesn't necessarily mean it's code compliant. Okay, so let's examine some of the stuff that we do see or that we do know. And that's the important part of this video. So assuming that it's a auxiliary gutter, let's read what it says when it comes to conductors in parallel. So obviously we have 3 sets of parallel here. It says, where single conductor cables comprising each phase, neutral or grounded conductor of an alternating current circuit are connected in parallel as permitted in 310.10G. If you might remember in the 2017 code, it was 310.10H. So slight change for the 2020, okay? It says the conductors shall be installed in groups consisting of not more than 1 conductor per phase, neutral or grounded conductor, to prevent current imbalance in the parallel conductors due to inductive reactance. So the first thing that I observed in this picture that really stuck out to me was the fact that you have 3 sets here, but 2 of them are going through this LB, and then 1 set is going through this separate, and I assume this looks like a rigid nipple, that's coming down and terminating, okay? So the characteristics of each of the raceways are not consistent, okay? So I've got 2 of the 3 phases running through LB, and I have 1 of the phases running through a single nipple. Okay, so again, group consisting of not more than 1 conductor per phase. Well, as you can see with the tie wraps here, this has a group that has more than 1 conductor per phase in it. So I'm concerned about inductive reactance, but we know how resilient electricity is. We know that it's going to run, and it'll probably outlive us all, but code-wise, this is one concern that I might have. Okay, now let's move on. The next thing we look at is, okay, we're assuming this is an auxiliary gutter. Let's look at 366.22a. It says sheet metal auxiliary gutters. It says the sum of the cross-sectional area of all contained conductors and cables at any cross-sectional area. So if I took a cake and I literally cut it down the middle and I'm taking the actual analysis of that cross-sectional at the point where I made the cut. Okay, think of a wireway or auxiliary gutter. It's that given point that I take that section review. Okay, I literally look down that middle. In this case, it could be right here where all these conductors are. I could literally take a cross-sectional analysis right here, and I would take all of those conductors and take their approximate area based on Chapter 9, Table 5, whatever these are, THHN or XHHW, whatever it would be, and then I start doing the math just like I would do a raceway fill calculation. Once I come up with that value, now I have to look and see what does 366.22a try to tell me. And here's what it tells me. It says the sum of the cross-sectional area of all contained conductors and cables at any cross-section of this sheet metal auxiliary gutter shall not exceed 20% of the interior cross-sectional area of the sheet metal auxiliary gutter. So in this case, the worst case scenario seems to be right here, because I got conductors going this way and I got conductors going this way. So right here's your worst case scenario. It seems awful full. So if I was going to do this, I'd have to calculate the approximate area of all those conductors that are in that swath, if you will, that section, that cross section that I'm examining. And then I take the gutter itself, in this case, and you take the height and the depth of it, and we calculate that point right there. People will say the actual the height and the breadth or whatever, but that's how we're trying to get a value. So if it's 14 by 14, it's 196. And then whatever the number of conductors that are there, I have to make sure that I don't exceed 20% of that 196. Okay? And so that's the limit. Now, as far as this image, I really would spend a lot of time examining this to determine how many conductors I have, and you might be able to guess, but at the end of the day, it's a guess. Okay? I probably can deduct it by looking and trying to, I don't go there. I'm going to assume that it doesn't exceed the 20%. It passed inspection, even though there's other issues here, because I really can't tell in this graphic. Okay? I really can't tell. So again, my point is assumptions. And we don't want to go beyond the normal assumption. We want to go with what we know, what we can see. Okay? So it could be a violation of that cross-section area, and that was some of the comments that we had. But I'm not going to speculate on it. I could try to add it all up, and if you want to do that, go for it. And again, that would be just another code reference that it would violate if you were an inspector or a studious installer. Okay? Now, let's go a little further. Now, let's talk about 366.23a. And this is where we would make some kind of adjustment for the number of current carrying conductors that are in this wireway. Okay, excuse me. You see what I did? Auxiliary gutter. Now, it says, and you see right here on the screen, and you follow along with me, it says the adjustment factors in 310.15c1, which I'll remind you was a change from 2017. It was 310.15b3a. Okay, so we had slight change. It says the adjustment factors shall be applied only where the number of current carrying conductors, including neutral conductors that are classified as current carrying, okay, under 310.15e, so that's where you would go to clarify whether or not the neutral is a current carrying conductor or not. And when it exceeds 30 at any cross-sectional area of the sheet metal auxiliary gutter. So that one we just did previously to determine whether or not we're exceeding 20%, use that same value. And if we don't have more than if we're not exceeding 30, then we don't worry about the adjustment because there's enough air in there for dissipation and of that type of thing. But when we exceed 30, okay, then we have to worry, and then that's when we have to apply the adjustments in 310.15c1, or if you're in the 2017 code, 310.15b3a. Okay? So then, if we're not exceeding 30 at that cross-sectional point, no harm, no foul. Okay? You with me? All right. And then, of course, the other goes into the bus bars that might be in there. And again, not an issue in this one, so we won't go into that. Now, let's move on to the next one. That is 366.58b, as you see here on the screen. Now, what's up with that? Now, in this case, if we're using an auxiliary gutter as a pull box, and one, I would argue that if we were going to call this an auxiliary gutter, which I don't know that it's supplementing space for this switch, and I don't know it qualifies under 366.2 as being called an auxiliary gutter. If that's where you want to be, then we'll say it. So that wherever camp you're in, this lesson's for you. Is it being used as a pull box? Now, if it's being used as a pull box, otherwise, why would you have it? And since they are offsets, you wouldn't pull this straight through. You would be using it as a pull box, okay? Now, in that scenario, because we're going to pull the conductors out and we have to reroute them down into the switch gear. All right, here you go again. Down into the switch, period. Okay, not switch gear. All right, so, gotta watch myself here. All right, so 366.58b, let's read it. It says, where insulated conductors 4 AOG or larger are pulled through an auxiliary gutter, the distance between raceway and cable entries enclosing the same conductors shall not be less than that required in 314.28a1 for straight pulls or 314.28a2 for angle pulls. Okay, so in looking at this picture, these right here could conceivably be pulled straight through. Okay, Here we would argue whether or not this could be pulled straight through or whatnot. And if we're treating it as a pull box, then it sends us back to the application. Let's focus on the fact that they're being pulled, it's being used as a pull box. Whether they stop or not, it's still being used as a pull box, okay? All right, now let's focus on these over here. So if it was A1 in 314.28, it would be 8 times. Remember, straight is 8. That's a little way to remember it. Straight is 8. So 8 times. So if this was the box that we did, and we did was 14 by 14 by whatever the width is, then we've got 14 inches. Now, if this is a trade size 3 coming in, okay, then we've got to do a little math. So if this is a trade size 3, then it would be 3 times 8, and that'd be 24 inches. Well, I don't think that from here to here is 24 inches. Okay, so again, you're going to have to determine whether or not this is being used as a pull box. I didn't install it. You didn't install it. So what we're doing is sharing some of the things that the installer has to be aware of if they're pulling it. But the nature of these tends to lead itself to a straight through pull, okay? All right, so do we have that distance? And here's the important thing here. As you read it, it says, the distance between raceways and cable entries enclosing the same conductor shall not be less than that required in 314.28A1 for a straight pull, 314.28A2 for an angle pull. Okay, so the angle pull is 6 times, all right? So one of the things that we have to consider is, do we have the adequate separation? Now, I would also argue that if these are considered angle pulls, from here to here, if this is a trade size 3, is it 6 times? So if I go 6 times 3 is 18 inches. Is it from here to here 18 inches? Is it from here to here 18 inches? Again, the semantics of 366.58b is stating where insulated conductors 4 gauge and larger are pulled through an auxiliary gutter, okay? Now, it's not talking about the physical pull through. It means they're coming in as part of the install. They're being pulled through. In other words, it's moving through or transgressing through the auxiliary gutter to get from point A to point B, okay? In that scenario, if it's pulling through it, in this case it is, then it is being used as a pull box, okay? Otherwise, what would it be there for? In that scenario here, I have to make sure that I have the separation between this raceway and this raceway for angle. And if it's a straight pull, it's 8 times from here to here, okay? So that's the things that we really want to focus on again. Now, not to reiterate the fact that I also have some other issues here when it comes to the paralleling, and we'll talk about that even more in detail in a second. To me, we have potentially a pulling issue, a pull box issue sizing, okay, for this gutter. All right, so that's another thing to think about is when you're dealing with this aspect of it. Now, let's keep on going. Now, also looking again at understanding whether or not this is an auxiliary gutter or a metal wireway. That takes us back to the definitions. And in these definitions, you'll see that a metal auxiliary gutter is a supplemental wiring space, okay? A supplemental wiring space at meter centers, distribution centers, switchgear, switchboard, and similar points in the wiring system, okay? That's what it is. However, if we decide that it is a metal wireway, then it says sheet metal trough with hinged or removable covers for housing and protecting electrical wires and cables, and in which conductors are laid in place after the raceway has been installed as a complete system. Okay? So, one of the different aspects of this too is you see that wireways are referred to as placed after the raceway is completely installed. Okay? And if you look up at auxiliary gutters, you don't really see anything that refers to it as a raceway. Okay? So kind of subtle differences in what we're dealing with here as well. All right? So it's an auxiliary gutter is supplemental space, and usually it's designed to go with the equipment to afford them that space. And then, of course, you have the wireway, which is a raceway, and it is part of the complete system. So that's the kind of things that you want to look at, okay? All right. Now let's go on and examine it now as if it was a wireway, for those that are in the wireway camp. Okay. Now, 376.20, again, is very familiar. It's talking about conductors connected in parallel. So it says, where single conductor cables comprising of each phase, neutral, or grounded conductor of an alternating current circuit are connected in parallel as permitted in 310.10G, which again was 310.10H in the 2017 code. It says, this is important, it says the conductors shall be installed in groups consisting of not more than one conductor per phase, neutral or grounded conductor. Now, if you examine the picture again, we not only have this issue we talked about here, but it also is over here as well. Because you notice that right here coming out of this LB, which you can't see, I only have a yellow and a gray, and I might have, I can't really tell, might have an orange in there, but everything else is running out of this raceway here. So there, oh, wait a minute, there's one, there's a yellow, there's an orange, there's an orange, there's an orange, and there's a yellow and there's a yellow. So here, all of the phases are in this one, but I don't have anything but a neutral and one of the yellows in here. Again, that's a fundamental problem of grouping and how we're running these. And we haven't even gotten into an application of what 310.10G is all about. So I understand the space might have been limited for this install. I understand they did what they had to do. They felt they had to do this. But there's some things that are really fundamentally wrong with this. Now, will it continue to run? Absolutely. It probably will work fine. Okay? But is there fundamental problems with this that could cause other problems? Yes. Okay? And the code, the National Electrical Code, is a minimum safety standard. Okay? If you don't believe this is an issue, then you need to submit a public input to the code making panels. And they will look at your public input and comment on it. But unless you provide substantiation, guess where it's going? It's going in the waste box or the trash can. You have to justify it. This is in the code because it was at some point justified, okay? And we won't get into the physics of induction and inductive reactance. We won't get into that. But there is an informational note here to remind you, for the purpose of having all the parallel conductors sets within the same group, is to prevent what? A current imbalance. Now, conductor lengths and things like that, there is different level of resistance per foot on these conductors. And so when we run them in parallel, we're trying to keep all of the characteristics the same. So if one conductor is longer than the others, then it has fundamentally a different value of resistance overall, which means that as the current divides, it doesn't divide evenly or attempts to divide evenly. And that's the whole purpose of running it in parallel. So you kind of defeat that purpose. And I can tell you in this installation that certain conductors, even though they're not following the general rule here, are probably not the same length. Okay? So again, I'm not going to speculate. That would be me guessing. I'm not going to pull out a ruler, but we got to remember those fundamentals. Now, the other thing is you notice the way they run equipment grounds and things like that aren't consistent here. Okay? And we know that when you're running equipment grounds that they have to be the full size in each raceway. Okay? Unless you're using the raceway itself as an equipment ground. But if you choose to use the wire type, then it has to be full-sized in all raceways based on the size of the overcurrent device. But I'm getting a little ahead of myself, so we don't want to go there. All right, so now let's go to the next point. We're at a wireway now. We next get to 376.22a. And it says cross-sectional area of wireways. Now, something familiar with the gutter? It is 20% of the interior cross-sectional area. So it's the same exercise that we did for an auxiliary gutter. It's the same exercise that we would do for a wireway. So we won't rehash that again. But we can't exceed that 20% of that cross-sectional area of that wireway. All right? Okay, and again, you do that math based on that cross-sectional area, width, height, and multiply the width times the breadth, or the width times the depth if you're looking for that one point in time as a cross-sectional area to give you a value, and then you take that and you want to make sure that you don't exceed 20% of that. Now, where do you get the values for the conductors? You go to Chapter 9, Table 5, and we have the values there. Okay, so again, that's another exercise that we might do for another time. But that is something, and again, the reason I'm not going into too much depth of that is because I really can't tell what's here. I really can't at any cross-sectional area. It just seemed like a lot right here. Right here, it might be a lot, but I'm not going to comment on it because you know what, it'd be speculation. But it's just something for you to think about in your install, and that's what the point of this is, for you to think about it. Okay. All right. So now again, we have the definitions, and we looked at it, and that was that cross section area. I think I flipped back. So let's go on. All right. The next thing we want to look at here is adjustment factors for when we're going to have more than 3 current conductors. So what we're looking at here is the same as kind of what we saw in the auxiliary gutter aspect. Okay, very similar. Okay, is number 1, it says the adjustment factors in 31015C1, which incidentally used to be 31015B3A for those that are still plugging away in the 2017 National Electrical Code. That's where it's at. We had some numbering changes, some section changes, subdivision changes in 310 for the 2020 code. So I encourage you to watch my video that explains the changes for 310 so you don't get lost. But it is a much better flow in 310. They did a much better job on that code panel. Okay, so adjustment, it's the same thing here. You don't have to worry about adjustment factors until you exceed 30 at any cross-sectional area. So right here, if this exceeded 30, and I don't know that this would exceed 30. So it might be an issue exceeding the cross-sectional value of 20%, but I don't think it exceeds enough at that one point in time for you to bring in an adjustment factor. Okay. Now, if they all came in right here and then they all ran together across and then went out down here or something, then any cross-section would be the same, and you calculate that, but then I don't think you'd exceed 30. And the whole concept in here is there's a lot of airspace. Okay. But we got to remember, we don't want to violate the cross-sectional area rule. So that's something you might have to calculate, and it can't be more than 20%. Okay. The next thing that we want to look at, and I'm looking at this if it's a wireway, is deflection of insulated conductors. Now, this is a pretty important one, 376.23a. So as they come in here, they deflect. So this is just going to tell us what distance we have to have here based on 312.6a, as if it was 1 wire per terminal in that table, the deflection. Okay. It could also be a wireway that changes direction, and where the deflection is greater than 30 degrees. Okay, then that's an application where we have to make sure that we have a dimensional requirement that meets table 312.6a. Okay, now I'm just speculating here, but we don't want you to do that. But what we're saying is I want you to be aware of deflection rules. So it says where insulated conductors are deflected within the metal wireway, so it comes in right here, check these out, and they're deflecting this way. Okay, whether it's at the ends or whether it enters into the actual wireway. Okay, it says where the deflection of is greater than 30 degrees. That's for sections of wireway. Okay, but we're talking about this deflection here, where there is a deflection. Then basically it says I have to have a dimension this way that corresponds to 312.6a. Okay, so you go to that table for the largest conductor and you'll look at 312.6a, and it might say it needs to be 6 inches. So this would be a 14 by 14. That's not going to be a concern as far as that deflection. But it is something that I want you to be aware of, because sometimes you have wireways that might be very stubby wireways, and the number of conductors come in and there's not enough room to deflect. Okay, so it has to at least have a certain height in order to meet that deflection. Okay, so just things to think about so as you're designing your system. Okay, again, I just wanted to bring it up here. Nobody commented on that, or somebody might have said deflection, but I don't feel there's a deflection issue here. But again, I don't know the size of this wireway, if that's what we're going to say this is a wireway. I don't know the size of it, to be honest with you. Okay, all right, just wanted to bring it out. Now, as I said before, this wireway being used as a pull box. Now these conductors in here are 4 gauge and larger. Pretty obvious if it's parallel sets for 800 amp, then that's what we're dealing with. At that point, we look at it and we go, all right, so if that's the situation, if they're 4 gauge and larger and they're pulling through a wireway, it says the distance between raceways and cable entries enclosing the same conductors shall not be less than that required by 314.28a1 for straight pulls, 314.28a2 for angle pulls. So again here, if this was a trade size 3, then it would be as we've done before, and we always do it to check our accuracy. We're going to go 3 times, if it's a straight pull, it's 8, 24 inches. So if this is being used as a straight pull, straight through, then I would say that I had to have at least a 28 inches. Okay? That's again if it's being used as a pull box. I don't know this installation, how they used it, but I'm just bringing it to your attention. Okay, not necessarily my biggest concern, but I do want to make it something that you're aware of. Now, again, here, angle pull to here. In this case, if it's being used as a pull box, making it aware, then in this case, it would be 6 times the raceway. Okay, so here, this size to here, that we have to make sure we have this separation between, okay, distance between them. Okay, and in this case, if it was a trade size 3, then I want to make sure I have a 24-inch, no, it's 6, so it's 18. 6 times 3 is 18 inches separation. I don't know that we have this here, okay? So just some things to consider, and a lot of people called out certain things, but nobody really talked about that if it's being used as a pull box. I would argue, based on my experience of a pull, that it is very much being used as a pull box, okay? All right. Now, again, let's move on again. We're also going to look at a couple other things. Regardless of whether this is being used as an auxiliary gutter or metal wireway, regardless. Again, that takes us to 366.20 or 376.20. Parallel conductors. As we saw before, the grouping is not right. Over here, I see only one conductor of the set in a neutral, and over here they're all running through this other nipple right here. So they are not consistent. I do have groups, whether you're running whether it's an auxiliary gutter or it's a metal wireway, both of these are violating, whether it's these over here where you see some of them are running through the LB and then the others or one phase is running through this one here. But again, all of the equipment grounds are running through here and not any running through here, okay? And maybe his concept is that I'm using this as the equipment grounded conductor, but then I'm not over here. Okay, if you're going to choose to use a wire type and you're going to have it paralleled, they have to be full-sized in each raceway. Okay, if you choose to use the raceways and it's permitted for whatever wiring type you're using under 250.118, if that's the case, then go with that. But here we're using wire types in the aspect of it. So in that scenario, I got problems with that too, but we'll talk about that in a second. So whether or not you're running a auxiliary gutter or you determine that you're doing a metal wireway, which is probably what it is, then in this case, you still have the same issues because it's not complying with 310.10G. And we're going to look at that in more detail here. But what does that tell us? We got problems here that the installer wasn't aware of. They try to make it look pretty, and they did what they had to do based on the space they had. But right now we're looking at a potential for this gutter or this wireway maybe not being large enough, maybe not having the space if it's used as a pull box. But now we fundamentally know that we have problems with the paralleling aspect of it. So again, whether you believe the other one or not, now we got something that really needs to be addressed. Now let's look at 310.10G, which used to be 310.10H, okay, for those that are to 2017 code. All right, and it doesn't matter whether or not it's a gutter or wireway in this case, okay? It's synonymous. Paralleling. First thing we read in 310.10G, G1 is the general rule, and it says aluminum, copper-clad aluminum, or copper conductors for each phase, polarity, neutral, or grounded circuit shall be permitted to be connected in parallel. That's electrically joined at both ends, okay? So it's replicating one conductor, but it's using multiple conductors because at the ends, while they might be separately terminated, at the same characteristics, same length, they're replicating a single conductor because of how they're being run, okay? And I get the benefit of the ampacities of each conductor being the sum of those, okay? Always remember terminal limitations, 110.14C, because you're only as good as the termination you're going to. But again, that's for that. Go watch my D-Rating Demystified to get more on that kind of concept. Okay, so we'll assume these are obviously 1/8 and larger, and they're paralleling. So of these parallel conductors, they have to be the same length. I will question whether these are the same length as these, but let's not get into assumptions. We're not measuring. So as far as conductors are concerned, each phase, polarity, neutral, grounded circuit conductor, equipment grounding conductor, or equipment bonding jumper shall comply with the following. Okay, they have to be the same length, same conductor material. That's where we have a problem here, whereas you have equipment grounds running here, but over here, I don't have any equipment grounds running in this raceway, okay, or this LB, for example. So characteristics aren't the same. Not to mention the lengths might not be the same. They have to be the same circular mill. If I'm using wire type here, then I have a problem over here because I don't know what the circular mill is of here. Okay, might not be relevant if I'm using the raceway as an equipment grounded conductor, but they would all have the same characteristics if they all were the same type of raceway. Okay, not the case here. Some of the other things that we want to make sure you know when we talk about characteristics, could I have phase A be copper, phase B be aluminum, and phase C be copper? Absolutely. As long as all of the same characteristics for that phase are the same. They're all copper or all aluminum, depending on what you do. I can't have copper and aluminum in phase A, for example. So that's just an example of the same conductive material or conductor material characteristic. Okay, so I could have aluminum on phase A, copper on phase B, as long as I know I'm sizing it right. And remember, copper tends to be larger than aluminum. Okay, just remember that. All right, so they have to have the same insulation types. So I can't run a phase A. I can't have THHN, THWN, and XHHW as that phase. Okay, that's each phase. Okay, so they would all have to be THHN, THWN-2, or they'd all have to be XHHW. Okay, so we're talking per phase. Okay, so A phase is one separate thing to consider, and then I consider B, and I consider C. Okay. You with me so far? So that's the characteristics. And they all have to be terminated in the same manner. Now, when it comes to equipment grounded conductors, here's where I tend to argue with people and say, what's the same manner? The same manner means that if they go to the terminal bus and you have one bus and you have a separate lug, they're terminated in the same type, means the same type of lug, same compression, everything the same, then I don't think they all have to be on the same bus when it comes to equipment grounded conductors. Okay? We're not paralleling those because the code doesn't allow them to parallel equipment grounded conductors. Yes, they have to be full size in each raceway, but we're not paralleling those per se in order to meet the compliance requirements here. We're doing what the code tells us we have to do in 250.122, and we'll get to that in a second. But that's a whole nother story, and I have a public input for 2023 to try to clarify that. So in this case, we're really focused on what we see here. And we've got problems. Everything looks terminated the same characteristics, so I don't have a problem with that. I'm assuming the insulation's right, so we don't have a problem with that. So far, other than the fact that we're using equipment grounded conductor, one, we have the wire type, and then the other, we're using an LB. For that, a little bit of a problem with this application because we're using that LB as a theoretically a conductor at this point. You with me? All right, so let's continue on. Now, here's where we come into a little problem. 310.10G3. Which was 310.10H in the previous, I can't remember if it was subdivision or item 3 as well in the 2017, but you get the gist. It was there. And here's what it says. It says, we're running separate cables or raceways. That's what we've got here. There's not a single one. There's separate ones. It says the cables or raceways with conductors shall have the same number of conductors and shall have the same electrical characteristics. We're talking about the raceways here, or we're talking about the cable assemblies. Same characteristics. In this case right here, we don't have the same characteristics. I've got nipples, and then I got LBs. Okay, so these are raceways that are being run. They are not of the same characteristics, so we're a little bit of awry here. Okay, and again, they don't have the same number, so that's a problem. Okay, you see over here, I've got one set in here, and in this one over here, I've got two of, let's say this is C phase. I've got two C phases in here of the set and only one in this one. So it's not being run consistently. There's not the same number of conductors in these separate raceways. Again, that creates inductive reactance and that creates a problem that we want to be aware of. Okay. Also, that additional heat that comes from inductive reactance can play havoc on the insulation of these conductors depending on how severe it is. Okay, because it is rated for 90 degrees C most times, but again, the terminal limitations are going to limit us to usually 75 degrees C for most applications under 110.14C. So if we get to an application where we have elevated ambient temperatures and we've got a certain number of conductors that are together in a raceway, over time that heat can creep up, but now you incorporate inductive reactance in there and magnetic heating, and you could have a problem with this insulation. Okay. So it's some things that we want to think about. Now, let's move on because now we want to say, okay, let's talk a little bit about those equipment grounded conductors. Okay, now we know these aren't services. When people said originally in the comments that the service conductors and everything, service conductors wouldn't have the equipment grounded conductor run with them. Okay, so in this case, we know that these are either feeders or branch circuits, depending on the application that we're running, okay? So if that's said, and the reason I use that term that way, feeders or branch circuits, because those can together go in raceways, they can go in wireways, they can go in gutters, okay? But you got to be careful, because if it's an auxiliary gutter for a service, then you wouldn't have equipment grounding conductors in. You might have equipment bonding conductors, or in that case, you'd probably have supply side bonding jumpers in there. So understanding terminologies are real important. Okay, now I don't want to get off track, but really encourage you to watch our videos on grounding and bonding, because you want to understand the differences in the two. So let's look at the screen here. Again, we're talking conductors in parallel, and we're going to talk about the equipment grounding conductors. And here's what it says. For circuits of parallel conductors as permitted in 310.10g, which we've been looking at in depth, it says the equipment grounding conductor shall be installed in accordance with 251.22 F1 or F2. Now, we're not going to deal with F2 because that's a multi-conductor cable, like an MC, tray cables. That's for a different story, because that's not what we have here. Here, we're going to deal with F1, and we're specifically going to deal with F1B versus F1A. Because F1A deals with if we did all this in one single raceway. But in this case, we have multiple raceways. So that's what we're going to deal with. So we're going to look at that. So here we go. Now remember, we're not going to examine F2. That's for multi-conductor cables. We're dealing with raceways. Now, A says this. It says single raceway or cable tray, auxiliary gutter, or cable tray. If the circuit conductors are connected in parallel in the same raceway, auxiliary gutter, okay, if you determine that's what this is, okay, it says, or cable, a single wire type conductor shall be permitted as an equipment grounding conductor, okay? The wire type equipment grounding conductor shall be sized in accordance with 250.122 based on the overcurrent protected device for the feeder or branch circuit. Okay, so we said this was an 800 amp, and we've got raceways. So we're not really so much focusing on the auxiliary gutter. What we're really focusing on is what comes in via the raceways that are coming into this gutter or wireway, and what's going out to the actual switch. So in this case, we've got equipment grounding conductors run. You can see it here, okay? But it requires them at this point if it was a single raceway. In that scenario, and the reason that we have it called out gutter here, because gutters aren't raceway, but the same principle applies in your application. All right, so in here, we have to make sure that we understand that we're not dealing with a single raceway in this application for what me and you are concerned about here. We're concerned about these raceways and how they get from that gutter or wireway, which is a raceway, to this switch. Okay, that's our biggest concern. So 251.22 F1A is not really our concern right now. Now let's look at B. Okay, 251.22 F1B. And it says for multiple raceways, and that's what we've got. It says if conductors are installed in multiple raceways, which they are, and are connected in parallel, which they are, a wire type equipment grounding conductor, if it's used. Now we say if it's used because you could use the raceways as your equipment grounding conductor. Now I work for a wire and cable manufacturer. I like when you use wire. Trust me, I'm promoting wire. But the code in 250.118 does allow certain wiring methods to be used as an equipment grounding conductor. So, but if I choose to use the wire type, which we have here, they are using it, okay? And you can't interchange it, despite what somebody might tell you. I can't have 4 raceways and pull equipment grounding conductors in one and then use the raceway in the 4th one, because they wouldn't meet those characteristics that we saw earlier, okay? And it becomes really confusing, and a lot of people would like to pound their chest and start arguing, but I don't think that's the intent of what we're trying to discuss or the intent of the code, okay? All right, so let's kind of move forward with this. So what does it say? If I use the wire type, if used, it shall be installed in each raceway and shall be connected in parallel. Well, as you can see here in the image, all of them are coming here for all of these raceways that are coming together rather than through here. So there's nothing running through here, but everything is running through here, okay? So fundamentally, some problems here that. Now, how do you size it? We know that we size those equipment grounding conductors based on the size of the overcurrent device. And in this case, it was 800 amps. So I believe it's 1 aught maybe in all of the raceways, okay, is what you're going to need for that 800 amp, okay? I might be mistaken, but I think it's 1 aught, all right? So it's installed. Otherwise, you get the point. It needs to be installed in each raceway, and it would be installed in this LB as well. Okay, it's not done in here. So I have a problem. So 250-122 F1B is part of our concern as well. We're stacking it up now. Is part of our application. All right, you with me? Now, many people at this point would want to discuss, and this graphic shows it pointing right here, but really we're talking about it pointing, it should point right here. I'm sorry. When I moved this up, I forgot to move the point down. And we're talking about right here, and they're referred to as bundling. Now, 310.15C1, okay, is the application that we're going to look at here, and this is for the 2020 National Electrical Code. And the 2017 code is 310.15B3A application. And it's where you got more than 3 current conductors. Now, let's read it. It says, the ampacity of each conductor shall be reduced as shown in table 310.15C1. And again, that's the 70%, 80%, 90%, whatever it is, 70%, 80%, 50%, whatever it is, depending on the number, it goes down. In that table, you have to take that into consideration. But this one says, for the number of current carrying conductors that are in a raceway or cable where it exceeds 3. Well, we're not talking about, even though this is pointing at a raceway, and it probably does exceed 3, we're really talking about this focus on this bundle. Even though this does apply to raceways, and this is considered the raceway, this right here, if it's a wireway, all right, but we're really focused on the question people have about this bundle here. Now, it looks neat. Everybody brings them together. Now, will it dissipate heat? Not as well as it would if they were separated, but it's not nearly the concern as if it was in an enclosed raceway, if you will. This is in the switch, and it's commonly done in panels, okay? So I do want to address this because some people will look at this a little differently. Notice that it says OR right here. We call this the power of OR. It would be this and that if you had an and, but the OR looks for 2 different things. So it's looking for the number of current carrying conductors in a raceway or cable that exceed 3, or it says where the single conductors or multi-conductor cables not installed in a raceway are installed without maintaining spacing for a continuous length longer than 24 inches. Now, I would argue that this right here, which is 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 9 current carrying conductors. These neutrals may or may not be a current carrying conductor. Don't know the system. And they're bundled, and they might be bundled at this point all the way up. Might be longer than 2 feet. And they are not in a raceway. Okay? So people would be at that point really quick to start doing a calculation and reducing the ampacity. And that was one of the questions we had on there. So then it brings you into this question and like, am I screwed? What can I do here? We do this all the time. That brings us down to, and that's where my graphic should be pointing, it says 310.14, which used to be 310.15A2. Now it's 310.14A2, and it's selection of ampacity. It says, where more than one ampacity applies for a given circuit length, the lowest value shall be used. When we say the lowest value, that is you have a 90-degree value and you have a value of what the ampacity would be before you apply any adjustment and corrections and what it would be after you apply adjustment and corrections. And you create a new ampacity, okay? We used to call that allowable ampacity, but we got rid of the term allowable in the 2020 code, okay? It's just literally what is the ampacity, literally what it is. And so we alter the ampacity of that conductor. So if I stick a conductor in a bunch of bundles and I do adjustment and correction from the 90, then I'm going to have a conductor, provided I can do it from the 90. That means the insulation is rated at 90. That's the only time that I can use 90 to adjustment and correct from the 90. And I have a new ampacity value because of that. And that conductor now, this is what the ampacity is. Well, out in the raceways, I might not have more than a certain number of conductors. I might not have more than 3 current conductors in the raceway. Or I might not have an elevated ambient temperature. So that ampacity would be different. And it would be higher because I'm not applying any of those adjustment and corrections. So one of them is considered the lowest value. And that is the one where it applied all those adjustment and corrections. And now your ampacity actually came down because of all of those negative factors that you have to apply. Okay. The one that's not more than 3 current conductors or that's not in an ambient temperature higher than 30 degrees Celsius or 86 degrees Fahrenheit is going to have a higher ampacity value because it wasn't subject to those those adjustment or correction factors that we refer to as derating, well, then I have to use the lowest value. However, there is an exception. The exception says, and I'll read it right here on the screen, it says where different ampacities apply to portions of a circuit, and again, this portion is one portion of the circuit. Out here on the raceways that these all lead into is a different portion of the circuit. Okay, so where the different ampacity applies to a portion of the circuit, the higher ampacity value, that would be the part that's out here that's not subject to these adjustment and corrections, the same as it would be here, shall be permitted to be used if the total portion of the circuit with the lower ampacity, that's this portion here because you got to apply adjustment and corrections, does not exceed the lesser now of 10 foot or 10% of the overall total circuit. Okay, so if the value is the lesser of 10 foot or 10% of the total circuit, all right, let's use that example. If it's 100 feet and I do a 100-foot run and only 10 foot of that, this is the first way to look at it, a 100-foot run, the 10 foot of that, okay, is the part that's considered bundled, and that has a lower ampacity value now because of that condition. If it's not more than 10 feet and the run is 100 feet long, then I can ignore this condition and use the value that's at the 100 feet. You with me? Or the remaining, whatever the remaining 90 feet was, whatever that be. I can use that ampacity. That's one example. Now, what if my run is less than 100 feet? Then that's where I would utilize the 10%. Because it says that it can't exceed 10 feet or 10% of the total circuit. Okay? And it has to be the lesser of two. So the reason we have this in here is because we might have some installations that are over 100 feet or 100 feet or more. And then we might have installations that are less than 100 feet. And we need to have two variables. We need to be able to use the 10 foot or we need to be able to use the 10%. And to be honest with you, we have to choose whatever the lesser. So for an example, I could have 1,000 feet. I'm just saying. Okay? So 10 foot is probably going to be the lesser of 10% of that overall distance. So you see how that works? We have to choose to not exceed the lesser of the two. Okay? All right. So that's it. So that's going to allow me to be able to ignore this position right here inside of this switch. Okay? Whether you agree or disagree, it's going to be allowed to do that. Now, do I think that tying all these together is a good idea? Probably not. I'd rather have some spacing in there. I think people get sold that the fact that bringing everything together makes everything better. But you know what? I feel it would be better if you bundled your sets together and you put them in there and they separated a little bit and you took all your phases and everything that you put together, A, B, and C in the neutral, and did that together. I think that would look better. But again, that's an installation thing. You do have some allowances here in 310.14. So again, that's what's going to be allowance for you. Okay, well, that's it for that. Let's take it back to me. So that was my examining of the image that I put up there, and I just wanted to cover those are the main things. Now, there's other people that said that the switch wasn't secured properly because they saw only 3 screws. That might be a 110.3B. You have to look at the manufacturer. I don't have a copy of that manufacturer spec for that piece of equipment, so I'm not going to cover. They might only see, it might say only 3 needed or 2 opposite ends. I don't know that, so I'm not going to speculate on that. Other people made comments in that image about the EMT or rigid that's going from that junction box to the right. I'm not going to comment on that because, again, you can secure it up to 3 feet from the termination to the box, and I can't see out more than a foot, so it could be out there. I can't see it, so I'm not going to comment on those things. I'm not going to comment on the size of the equipment bonding jumpers. I'm not going to comment on all of those aspects of it because I don't know, to be honest with you, what size of the conductors exactly that we're dealing with, okay? So I'm not going to comment on those applications on how you do that. But if you're the installer, remember there are factors when you're doing bonding of raceways and things like that that you have to take into consideration. All right, and it's much different for services than it is for feeders and branch circuit applications. So for services, be very aware of 250.92 and all the aspects that are involved with bonding and raceways and things like that that's coming in that has service conductors. And be very conscious of all those rules otherwise, when you're dealing with feeders and things like that, because those are all important. So hopefully you'll catch one of our grounding and bonding videos and we can really go into detail about those type of things, because I'd love to discuss those things with you. Anyway, hopefully you got something out of this episode today. There's other little issues that you might comment on this video, but again, they're not blaring at us. There's no definitive proof, so we're not going to comment on those things. Till next time, folks, stay safe. God bless. You've been listening to Electrician Live with your host, Paul